see you. Yeah. They let me pick pictures. That's a horrible idea. Never let me pick pictures. Like you said, my name's Kyle. I am a professional services engineer here at Apollo. If you've talked to anybody about professional services, I've probably been there in some way, shape, or form in the background. Shameless plug here. If you guys want to talk about professional services, find me. It's awesome. If you guys have any questions or want to contact me after this, my handle on Twitter is not Kyle Schrade. It's always going to be Twitter to me. I'm sorry if we have any Twitter people in here. So what is the point of this talk? We always talk about how you should make things and what is your best practices and why are these good things. We're going to kind of take the opposite approach today. We're going to say everything that's bad, and this is why it's bad, and here's how we can kind of get around it, and kind of tell you why a best practice is a best practice. So with that, we have three overarching things that we're going to talk about today: schema, federation, and observability. So with that, let's hop into schema. Schema is the easiest one that we can all talk about, and one of the easiest things we can all talk about is naming conventions. The worst thing you can do for this is just randomly name things. That's how you can make everything feel bad. It's going to be just painful to go through things. And the easiest way to fix this is to just pick a naming convention. It's really not that deep. Pick something that you guys can stick to, because the worst thing you can do is pick something, then flip, then flip, then flip, and you're kind of in this random naming scheme again. We at Apollo recommend that your input types, your enums, and your scalars are Pascal-cased. Your field names and your directives are camel-cased, and your enums are screaming snake-case. Again, pick one. If this doesn't work for you, just pick something. If you just pick something and stick with it, it'll work way better than kind of flipping through things here. And why does this matter? The reason that this stuff matters is because you want your graph to have a consistent feel. You don't want people, depending on where they're going and how they're using things, to have a different feel. Is their naming supposed to be train-cased now? Is it supposed to be camel-cased? How is it supposed to work? All of that's really rough for people to use, and once you get more and more people to use it, you want them to have that consistent feel as they go through the graph. Your graph is also a data catalog. It tells everybody everything that could happen there, everything you can grab. And part of that is you want people to feel the same way as they grab their things. If they grab a review versus a product versus a user, you want that to feel the same. You don't want them to feel differently because they grabbed one thing versus another. It also clears up a lot of gray areas and questions. If you have train casing happening, is that the same thing as something without train casing? Are those the same fields? It's very hard to find that out. And with the consistent naming patterns, specifically in types, you can find that out a lot easier because you're not fighting each other in that case. This is a fun one for me. One of the things you can do, or not do, I guess, is don't return the thing. If you get an ID back, return that ID, do not link it to things. And that's how you can make something very, very painful to work with. And this is kind of a pain point because in RESTful world, right, we return a bunch of IDs, and then you have to go to another place to get that, and then you might have to go to another place to get that, and another place to kind of waterfall these calls together to get your full picture. In the graph, one of the beautiful things we can do is we can kind of take a step back from that, and we can go and do those calls. And that's one of the biggest things that matter here is if you don't return the thing, I have to go do all of these subsequent requests and go ask for that data over and over. So it matters because we're doing all of these calls back and forth between our client and our server when we don't need to. If you just return the thing, your graph can go do that request for you without you having to go do that. It also bleeds a lot of other concepts into your graph that don't need to be there. If you don't return the thing, everything becomes RESTful, and it's a very segmented part of your graph. Your graph doesn't allow you to link to the next type. It doesn't allow your type to go to the next thing. You're very much segmented into like, hey, I can get my review or my product, but then I have to go back to ask for the next part, and then the next part. And you're kind of flowing this thing together again. It becomes very hard to use as well. As you're starting to push things together and you do make those connections, I can make one request to get my products, my reviews, and maybe the user that gave that review. If I don't do these things and I return the IDs, I have to go find all these things myself. And then the other thing is that it allows your front end to stay connected without having to make those connections itself. So your graph can make those connections between all of your types, where if I don't return the thing, I have to go and make all those connections myself in the front end and do that mental math and that mental problem myself. Pagination. The thing to not do is just don't do it. Pagination is just not needed. You never need pagination ever. Oh no, I got to clap for that. That's not good. That's not good. The thing with pagination is we all have the n+1 problem in our graph. There's always a way that you can get another thing in a bigger data set and a bigger data set. Pagination is a great way, even if it doesn't work on your back end, just to do the middle ground, to say this is the top n I can get. This is as big as my data set can get. which is just nice because then you can kind of stop that level, right? You can say, at most, this is my biggest thing. Bonus points if you keep your pagination consistent. If you don't, some pagination is still better than no pagination, but if you can keep your pagination consistent, that's another bonus to just say, hey, no matter where you go in our graph, these lists all work the same. And again, why do you care? You can put a cap on your end. If you have 100 things coming back, you can say that's the max. You don't know if that's 100, 10, 20, 1,000. With pagination, you can put that cap on there, which is very, very nice. The other part is it removes the ambiguity. When you add pagination, you're telling them like, hey, this list can be this big. You may have stuff coming next. You may not have stuff coming next. When you don't have pagination, you'll never know if that's the full list. Is there another thing I can grab? Is there more in this data set? Without pagination, who knows? Again, similarly, how do you not use deprecated? Just don't use it. Just don't have an idea. You're making everything perfect the first time. Deprecated is great, right? You can upgrade your schema, or not upgrade, you can evolve your schema over time. And as things change, you can change with it. Deprecated is a great way to add to that and say, hey, this is no longer used, don't use it, but it's still dependent on a mobile client version, or somebody's still using it. We don't want to break them, but we don't want more people to use it. And why does it matter, right? Why do we care that you use deprecated? Deprecated is a great way to avoid versions. Versioning in a graph is very bad. It doesn't tend to work well. And deprecation is a great way to kind of move that forward and say, hey, this is a field that's no longer needed. It's no longer used. You shouldn't be using this. Use this other field. With that, in all of your deprecation stuff, you can actually add a reason too, which is great. You can say, don't use field A, use field B because that's the new version of this field. We talked about naming a little bit ago. Say you name something wrong. You can deprecate that name and say, hey, we named this wrong, go use this other field, which is a great way to do it. And again, we kind of talked about it a little bit. The other thing is you can evolve without breaking. So not only are you deprecating something, but you're evolving your graph over time without creating breaking changes, which is a really nice fact to do. As we just talked about versioning a little bit, another thing you can do is you can add versions. It'll make your graph horrible, truly horrible, if you just start adding versions whenever anything changes. And the reason is versioning is most of the time unnecessary, because when you're versioning something, you're changing something. If you change one type in one subgraph, does that constitute a new version of your entire supergraph? Probably not, right? 90% of your types don't change. One field is added here, one field is added there. That's not enough for an entire type change, or an entire new version. What we recommend is you evolve your graph over time. You have the same version, same endpoint, but maybe you add a field or you deprecate a field, and you kind of go along that pattern versus just saying, hey, this is an entirely new supergraph. So why does it matter? And we kind of talked about this a little bit, but are you really versioning your entire supergraph, or are you just versioning a type or two? Most of the time, it'll just be a type or two. You're adding a field, you're deprecating a field. You're not really versioning your entire supergraph. You're just versioning this one little type. And even then, you're evolving that type by a field or two, or you're adding a new connection to a new type. You're not really versioning your entire graph. And one of the things that this would cause, and this is just going to be fun for me to talk through, is it causes a lot of chaos in your front end. What ends up happening as you version these things, do you use version 1, 2, 3 of your graph? And even on that note, is version 1, 2, 3 different in the spot I'm using it? These versions create a lot of chaos because, number one, you don't know what's the newest version. And on top of that, does your part of the graph that you're using really change in that version? Probably not. Again, all it takes to do a new version, quote unquote, is really just adding or removing a few types or a few fields on that type. And that's very easy to hit. The other part that why you should care about this is you lose that single endpoint. So now instead of having that one endpoint that everybody can go to get the updated documentation, that entire data catalog of what's going on at their company, they're kind of forced to figure out which one of these multiple endpoints do I go to get to the most up-to-date version of everything. And that becomes hard. I'm sure everybody has up-to-date docs wherever you're at, because that's perfectly what we all spend our time doing. And that's just a hard thing to keep up as you go over stuff. So moving along, things not to do with federation is kind of the next section of this. We moved on from schema. Let's talk about the federated ecosystem a little bit and talk about some places we can make this go wrong. First one, and this is a fun one, is you can over or under federate your entire graph. There's an asterisk on this. We'll get to that asterisk. There is one use case where under federating is a good idea, but it's a very special case. The first thing you could do is, in theory, you could make every field from your supergraph come from a different subgraph. Now, why you would do that, I could not tell you why, but in theory, you could make every field come from somewhere else. That is just a nightmare of DevOps and making sure everything's up and all of that type of stuff. Imagine having 100 types and then all of a sudden you have 10,000 subgraphs. That just sounds like a mess of stuff to do. You also don't get a lot of benefit from that layer. You're really routing so many things that it's just making so many network calls back and forth that you're just going to fight yourself eventually. So to talk about the asterisks quick, on the other side of that, having a single subgraph and having a router is normally a bad idea unless you have some stuff you're shooting for. If it's your first subgraph and you're trying to get to a second subgraph, or you're going to split down that monolith, then it's actually a good thing to have that repo because you're in the process of getting somewhere. When you just have that and, hey, I'm never going to move off this single subgraph, it's not really a great thing because what you're doing is you're just putting another network hop for not a lot of benefit. Now, if you're using stuff from the router, it's great, right? If you're using @defer, awesome, stay with that, it's great. But if you're just putting it there to put it in front of one subgraph that's never going to change, it's really a bad idea. So that's kind of the two ends of this is where do you go? Like you have the two ends, right? I have one subgraph or I have way too many subgraphs. And the question we always get after that is, well, where do I split my subgraphs then? And I don't have an answer for you. There is no right answer. If anybody tells you strictly like this is perfect, you can poke holes in it. It's really not that hard. The best thing I can tell you is it's whatever your company and your teams decide it is. Because every company is different, every team is different. Some people love to have a bunch of stuff and have them very split apart. Some people love to have it one per team, one per VP, one per domain area. Everybody is different. So the best way you can split them down is whatever is right for your company. And again, why does this matter? The reason that over-federating and under-federating is a bad thing, specifically on over-federating, is you become a maintenance nightmare. You have to keep up so many subgraphs and so many version changes and so many things that you're going to have trouble adding to your graph at some point, involving that graph over time. And the other thing we hit on a little bit, if you have a ton of subgraphs, you have so many chatty graphs back and forth because they're only contributing one or two fields. And then it has to call to another one to get the other two fields, and the other one, and the other one. And you just become very chatty for not a lot of benefit. On the other end, if you don't use any of the router features and you just use the router and it calls to one subgraph and always only to one subgraph and you never have plans of adding that second subgraph or the second things, you're just adding a network hop. You're not really getting any benefit of putting that router there if you're not using any of the benefits of the router. So on the other side of that, right? So in federation, one of the things you can do is you can have entities. One of the best things you can do if you want your subgraph to burn, don't use them. Just copy everything around, copy paste it, and just, hey, here's user in every single thing exactly copy pasted. Federation allows you to extend types. Highly recommend it. If you don't want to deal with somebody else's stuff, you can just use their ID and say, hey, their subgraph can figure out the rest. I'm just giving you the ID to link over to their stuff. And that's great, right? The other side of that is you can actually copy paste everybody's stuff into your subgraph. Why you'd want to do that, I can't tell you, but it's something you can do. It's very, very painful to keep up everybody's version of the same type everywhere. And why does this matter, right? One of the beautiful things of federation is you can actually share things. If I'm a product team, I don't have to care what the reviews team does. I can just say, hey, here's your review IDs. And on the other side of that, reviews doesn't have to care what product it is. They just know product number 1 has these reviews, and they don't have to care. And that's beautiful because I don't have to keep up stuff that I don't know about. Maintenance costs. As a normal thing that we've talked about a few times here, the maintenance cost of keeping up everybody's type to be exactly the same in my subgraph when they change it sounds painful. And it is painful because if they make a change today, I have to make that change today. And I'm stuck in this maintenance cost over and over of keeping all of these duplicated types together and the same, and it just becomes problematic after time. And then the other thing that happens is confusion happens. As you copy these types into your stuff, who owns these types anymore? If I change a type in my subgraph, does that mean they have to change it in theirs, even if they don't own it? Or sorry, if I don't own it, then that's a hard thing to find out. And you end up finding out in the wrong ways normally because somebody broke something, and then your graph doesn't compile, and then your router isn't working, and then all of this stuff starts to pile on really quickly. So in the last section, we're going to talk about observability a little bit. And one of my favorite things you can do is you can fly blind. You can be like this picture, everything is awesome, but everything's on fire behind you. And there's really two places you can fly blind in the Apollo stack, or the federated stack. One of them is the router level. What is coming into your router? If you don't know that, that is just a missed opportunity of who is using your graph. The other part is the subgraph level. From the router, what are we calling to each of these subgraphs for? How are they doing? In traditional APM metrics, give you something, but it's not great. They tend to be very REST focused, and when they give you that stuff, it's something, but it's not great. It normally says, hey, we gave you back a 200. Congratulations, GraphQL always gives you back a 200. It's not that helpful. So you have these great availability numbers, but really it is how available is your service, not how many errors did it return, which is really what you're looking for in a lot of this stuff. So it becomes very easy to fly very blind. So again, why does this matter? One of the things I had a great engineering leader before tell me is, without looking at your phone right now, can you tell if your service is up? And that's a hard question, right? If you don't have these observability tools, it's very hard to have that answer. If you have these observability tools, what can happen is you can set these alerts and it can tell you, hey, your subgraph is misbehaving, it's having a problem right now. So if you're not getting a call, your subgraph is up. And having that peace of mind is very, very nice. If somebody was to get paged right now, do you know where you're going? That's the other beautiful thing of this observability. If you have that observability and something does go wrong, instead of having to log in, go to your APM, find out what's going wrong, track that down, see who's using it, and kind of go through this whole process every time, you can set those alerts to say, hey, this subgraph is having a problem, this team is having a problem, this thing is having a problem, which is great, because then if you get called in the middle of the night, those 3 hours of debugging turn into 20 minutes of, hey, this team's having a problem, call them instead of me. And then you can move on. The other thing, and this is a larger topic that happens, is when you try to talk to people, it's very hard. The graph world and the REST world are very different vocabularies around how things work and very different pictures. This allows you to have a much better picture to take to a REST team to show them, hey, this is what your APM looks like in a graph version, and it looks really similar to what they would have for their REST APIs. You can talk in very similar terms most of the time. The next one is load testing. The way you can do this wrong is just use any tool off the shelf, throw it at your graph, and say, hey, this is my number, and it's perfect, and it will tell me exactly how many things I need to run. There's a lot of pitfalls in this, like a massive amount of pitfalls in this. The normal thing that happens when you use these REST tools is say, did you give me a 200 back? You can modify a lot of these to do more, but that is the general idea of what a load testing tool sees as a successful request versus a not successful request. So as GraphQL returns everything as a 200, you end up getting really, really weird results because you're saying, hey, here's all my load, and then it just gave me 200 back. Does it have errors? Who really knows? So that causes a huge different number, and you can take that and you can run with it anywhere, but it's not a really good number of what your actual load is that you can handle. The thing that we would have to do to change these load testing tools is actually take and look at that response. Do you have an errors object in that response? And why do you care about this? If you go to a bigger enterprise and you say, hey, my service can handle this amount of stuff under pressure. If something is going to happen, we need to have this many pods. That number is going to be off. It's going to be off in some way, shape, or form. Maybe you overshoot it, maybe you undershoot it, but you're not going to hit it right on most of the time. So having that false positive and that happiness of like, hey, we did this, is a really hard thing because you don't know what that number is most of the time. And then you fall into this common trap of if something changes, there's a few other things that happen with load testing too that really help you with that false positive. Those tend to be, did I change my query? Because really a subgraph doesn't get one query over and over and over, it gets a set of queries. So you have to kind of replicate that to get a real number. And that's a hard thing to do because how do you kind of keep rolling over your queries, making sure they're using different values, doing a bunch of different stuff to make sure you get a closer number to what's real. And the other part is, did your query variables change? Because if you send the same variable over and over and over, you're actually going to hit a ton of the same caches. And most graphs have some type of cache in them to help them fight through this, right? They don't want to be overloaded with things, so they cache. So if you get the same request with the same variables over and over and over, you're really just testing your cache. So there's a bunch of these little pitfalls that you can fall into very easily. And the last one, the best thing you can do to make sure your Supergraph bombs is literally just test it in production. Don't do any type of testing before, just ship it to prod and hope for the best. There's a bunch of stuff we can do before prod to make sure our Supergraph is going to work, or at least somewhat work, right? We can't catch every problem, but we can catch a lot of problems. The first one we can do, composition, operation checks, schema linting, all stuff Apollo provides, use it. Is it perfect? No, it's not perfect. Does it help you catch 90% of your problems? Yeah, because you can't send a schema that's broken somewhere. Or does your schema compose? Yes or no? Are you going to break something that's currently working today? You can kind of find most of that stuff out right now instead of waiting until you get to production and then watching it burn and then like scrambling to revert everything. The other thing to note too is graph testing is hard. Nobody has truly solved like this is the perfect way to do your graph testing. This is how it's going to work and you're going to be perfect at it, and if it passes, everything's golden. It's a hard thing. There's a reason that there's not that standard tool yet. And one of the things you can do is you can do a bunch of stuff using your staging environments, using your lower environments, letting it soak for a little bit, watching how people play with it. See if it does blow up. If it does blow up, then you have a problem. If they can work through it and it doesn't have a problem, your change is good. But just shooting it to production is always a bad idea. And why do you care about this? Number one, it's prod. It's where you make your money most of the time. You don't want to take down the thing making your money and paying everybody's paycheck. That tends to be a really bad thing that people get angry about. Also the mental health, right? Who loves pressing the button and then like hoping and praying for like a few hours that like, hey, I hope my change doesn't break anything. Having that safety to know that when you do something, it's going to pass and it's going to work is a huge burden off your shoulders. So in recap, how do we watch it all burn? We name everything differently, so no consistent naming schemes whatsoever. We don't return things, we return IDs. We add pagination, pagination is never needed. You'll never need pagination ever. We add versions, everything should be versioned, every change makes a new version. We make our subgraphs way too big or way too small. We duplicate everything. We don't use any type of federated principles whatsoever. We just duplicate it and hope for the best. We cover our eyes and fly blind because nothing ever goes wrong. We do load tests. We take the number and just run with it because load testing will always be perfect forever. And then we only test our stuff in production is how we can make a very poorly made graph. With that, this is the survey. I'll leave this up for a second for doing feedback for this session. Oh, I got a counter. Nice. I can just watch that. Hey, man, take it where you can. Any questions? I have a topic table today. I am on table 2. Yeah. Again, this is my contact information on X. If you need anything, feel free. I will be running around today and tomorrow, so feel free to stop me and talk about stuff. With that, thank you. It's been awesome. Enjoy your time here. Enjoy everything else. There's a bunch of great speakers. And they're giving back.